Hello students, in this lecture we are going to see remaining problems of heat exchanger. So let's begin with I am writing the data for this problem. A counter flow heat exchanger. So type of heat exchanger is counter. I have identified it. Now I am going to draw the temperature profile diagram for counter flow heat exchanger. So this is hot fluid TH1 and TH2. Now cold fluid is entering from opposite side and its temperature increases. So TC1 to TC2. Difference between these two is theta 1 and difference between these two is theta 2. Having heat transfer area, so A is equal to 10.07 meter square, is to be designed to cool oil. So cooling happens for hot fluid. So I will write in two column format hot fluid, that is oil, whose Cp is given as, so m dot Cp, specific heat of hot fluid, is given as 2.1 kilojoule per kg Kelvin, so 2100 joule per kg Kelvin. M dot of oil means oil is hot fluid, so m dot H is 20 kg per minute. So 20 divided by 60, it becomes 0.3333 kg per second. From 70 degrees Celsius, so TH1 is equal to 70 degrees Celsius to a desirable limit by using cold water. Okay, so here what is cold fluid? Cold fluid is water. Cold fluid is water whose not CPH, it is water is a cold fluid. So CPC is equal to 4.2 kilojoule means 4200 joule per kg Kelvin, and mass flow rate of for cold fluid, that is water, m dot C is equal to 50 kg per minute. So 50 kg per minute means divided by 60, 0.8333 kg per second. Now heat transfer coefficient on water side, that is HW. Water side, nothing is given as inside and outside, so I will use the notation water and oil only. HW is equal to 400 watt per meter square Kelvin, and H of oil is given as 200 watt per meter square Kelvin. Find the exit temperature of water and oil. So what is the required answers? Required answers is number 1, exit temperature of water as oil is TH2 because oil is hot fluid. Just 1 minute. Initially they have asked water, so I will write water is a cold fluid, and exit temperature of cold fluid means TC2, and then oil is hot fluid, so exit temperature of hot fluid is TH2, and effectiveness is third is epsilon. So I will put the values here on the temperature profile diagram. TH1 is 70, so here I will put 70. Then cold water is available at 30 degrees Celsius, so TC1 is 30 degrees Celsius, that is missing from my side. So TC1 is 30 degrees Celsius, that is given. Okay. And asked is exit temperature of cold fluid, hot fluid, and effectiveness. So we'll go for solution. Now, if you look at the diagram, there is only TH1 and TC1 given. TH2 and TC2, two temperatures are unknown. So there is only one option in front of you. That is which approach? Epsilon NTU approach. So this is only the way by which problem is solved. So for that, if I want to use this, I need to calculate heat capacities of hot fluid and heat capacity of cold fluid. So CH is the product of mass flow rate into specific heat. This is for hot fluid, so H is attached, and this is for cold fluid, so C is attached. Okay, let's put the values of both. So m dot h 0.3333 cph 2100 2100, then m dot c 0.8333 into cpc 4200. So if I will calculate the answer, ch comes as 699.93 and cc comes as 3499.86. Okay, now in this case ch is less than cc, therefore C minimum becomes CH and C maximum becomes CC. Okay, CH is how much? 699.93 and CC is 3499.86. Now heat capacity ratio R, that is C minimum upon C maximum. So what is C minimum? 699.93 divided by 3499.86. Okay, so this gives as R is equal to 0.1999. This is R. Now next I will calculate NTU, that is number of transfer unit. It is UA by C minimum. So to calculate NTU I require C minimum. This is known to me. Okay, this I have calculated, C minimum. Now area is given in the problem as 10.07, so this is also known, but u is unknown. Now in the problem, if you look at the data, nothing is given about the tube dimensions. No inner diameter, no outer diameter, no inner radius, no outer radius. Even thermal conductivity of the tube is also not mentioned. So tube data is not given to us, means dimensions are not given. In that case, how to calculate u? 1 upon u is equal to 1 upon hi plus 1 upon ho. In the problem, nothing is mentioned about inside fluid and outside fluid, so you can use it directly. So 1 by assuming anyone as hi and anyone as ho. So hi is equal, let's say 1 by 400 plus 1 by 200. If I will calculate the u by this way, the answer comes as 133.33 watt per meter square Kelvin. Now I got u. So if I know all the things, I can calculate NTU as NTU is equal to UA upon C minimum. So what is UA? U 133.33. Area is given as 10.07. Okay, and C minimum is coming at 699.93. If I will solve this, the answer of NTU is coming as 1.9182. Now if I know NTU and R, I can calculate epsilon by effectiveness NTU formula. What is that? Effectiveness is equal to, this heat exchanger is of which type? Counterflow type. So for counterflow heat exchanger, the formula is 1 minus e raised to minus NTU 1 plus 1 minus R divided by 1 minus R e raised to minus NTU 1 minus R. Remember, this is the formula for effectiveness of counterflow heat exchanger by using NTU method. Okay, now I know NTU and I know R, so I will do it. NTU 1 minus R, this value I will calculate first. What is NTU? 1.9182. 1 minus R value is 0.1999. If I will solve it, it comes as 1.5347. Okay, e raised to minus NTU 1 minus R. If I will calculate this, e raised to minus 1.5347, my answer is coming as 0.2155. Now epsilon is equal to 1 minus 0.2155 divided by 1 minus R की value 0.1999 into 0.2155. If I will solve this, the value of epsilon come as 0.8198. So this is answer 1. So I got effectiveness answer. Okay, answer 3, sorry. Answer 3. Now, you know, effectiveness is also given by delta T for C minimum fluid. Delta T for C minimum fluid divided by maximum temperature difference TH1 minus TC1. Now, if you see, C minimum is hot fluid. So, what is delta T for hot fluid? TH1 minus TH2 divided by maximum temperature difference TH1 minus TC1. So, epsilon value I know 0.8198, 0.8198, TH1 70 minus TH2, this is unknown, divided by TH1 is 70 minus TC1. TC1 is given as 30. If I will solve this, TH2 is coming as 37.20 degrees Celsius. So this is your answer 2. Yeah, answer 2. That is temperature, outlet temperature of hot fluid. Now only TC2 is remaining. How to get that? You can write energy balance equation m dot h Cph Th1 minus Th2 m dot c Cpc Tc2 minus Tc1. But you know the product of mass flow rate and specific heat is called as heat capacity. That is already calculated. Okay, just put the values of heat capacity. Ch is 699.93. Th1 70 minus Th2 is 37.20 is equal to Cc 3499.86. 3499.86. Tc2 is unknown minus Tc1 30. If I will solve this, the answer of Tc2 comes as 36.55 degrees Celsius. So this is answer 1. Okay. So this is the end of the problem. Now we'll move to the next problem. That is problem number 18. Okay. Let's write down the data for this problem. Hot air at 66 degrees Celsius is cooled by means of cold air entering at 15.5 degrees Celsius. First find out the type of heat exchanger. Check it. Mass flow rate of hot and cold air. Okay. Specific heat for hot and cold air. Okay. U is given. Area is given. If the heat exchanger is operated in, yes, counter flow. So the type is counter flow. So draw the temperature profile for counter flow. This is for hot fluid, and from opposite side cold fluid is entering. Okay, so this is temperature profile for counter flow. Difference between these two is called as theta1, difference between these two is called as theta2. Now I will make a two column. One is hot fluid column and other is a cold fluid column. Hot air at 66 degrees Celsius. So hot fluid hai air. It is at 66. So TH1 is 66 degrees Celsius. I will put it here. 66 is cooled by means of cold air. So cold side also fluid is air entering at 15.5. So TC1 is 15.5. Tc1 is equal to 15.5 degrees Celsius. Mass flow rate of hot air m dot h is equal to 1.25 kg per second and m dot c is equal to 1.6 kg per second. Specific heat of hot and cold air. So Cph, it is given in kilojoule, so I will convert in joule. 1005 joule per kg Kelvin, and in the similar fashion Cpc is equal to 1005 joule per no 1050, it's my mistake, sorry, 1050 okay, multiply by 1000 to this, so 1050 joule per kg Kelvin. Now U is common data, so I will write here U is equal to 80 watt per meter square Kelvin. Area is also common, nothing to do with hot and cold fluid, so I will write it separately, 40.47 meter square. If the heat exchange is operated in counterflow mode, find the exit temperature of the both fluid. So required answer is what? Number 1 TH2 and number 2 TC2. So it is very much clear. If the two temperatures are unknown, that is asked in the question, that means we need to follow epsilon NTU approach to solve the problem. LMTD approach is not the option for this. We can't solve the problem by LMTD. So if I want to start epsilon NTU approach, I need to find out the heat capacity, CH and CC. What is CH? M dot H into CPH. And what is CC? M dot C into CPC. Number of times we have done it now. So M dot H 1.25 into what is CPH? 1050. What is M dot C? 1.6 into 1050. The answers are okay, just 1 minute. Here is one problem. I have solved this problem by taking this as 1.005. Okay, I have solved this problem by taking this as 1.005. So naturally I need to do it as 1005 and 1005 joule per kg Kelvin, multiply by 1000. So please correct it. It is 1.005. So multiplied by 10 raised to 3 means it becomes 1005. Okay. So accordingly, I will do the changes here. It has to be 1005. So if I will solve it, it comes as 1256.25 and this comes as 1608. Now if I am comparing CH and CC, CH is less than CC, that is C minimum is equal to CH and that is equal to 1256.25. C maximum जो बड़ा है, that is C maximum, that is CC, it is 1608. Okay. Now I will go for heat capacity ratio R, that is C minimum upon C maximum. What is C minimum? 1256.25. What is C max? 1608. So if I will calculate the R, it comes as 0.7812. Okay. Now the next part, NTU, number of transfer unit. The formula is UA upon C minimum. So what is U? What is U? U is given in the problem, 80. What is area? That is also given, 40.47. And what is C minimum? 1256.25. So if I will solve this, it comes as 2.5771. So if I know R and NTU, I can calculate effectiveness as, this is which type of heat exchanger? Counterflow. So it is 1 minus e raised to minus NTU 1 minus R upon 1 minus R e raised to minus NTU 1 minus R. So let's do it first. NTU 1 minus R. NTU value is 2.5771. 2.5771. 1 minus R is 0.7812. 0.7812. If I will solve this, it comes as 0.5638. 0.5638. So e raised to minus NTU 1 minus R, if I will put the value of this 0.5638, I will get the answer as 0.5690. 0.5690. Okay. Now let's go to the epsilon value. Epsilon is equal to 1 minus e raised to minus NTU 1 minus R. It is 0.5690 upon 1 minus, what is the value of R? 0.7812 into 0.5690. If I will solve this, the answer comes as 0.7758. 0.7758. So this is effectiveness. But epsilon is also equal to delta T for C minimum fluid divided by maximum temperature difference TH1 minus TC1. Now look at this. C minimum is CH, means hot fluid. So hot fluid, what is the delta T for hot fluid? TH1 minus TH2 divided by TH1 minus TC1. So epsilon value I know 0.7758. TH1 is 66 minus TH2 is unknown. TH1 is 66 minus TC1 is 15.5. 15.5. If I will solve this, TH2 is coming as 26.81 degrees Celsius. Okay, so this is answer 1. Now if I am writing energy balance, Q is equal to m dot h CPH TH1 minus TH2, okay, is equal to m dot C CPC TC2 minus TC1. Okay, this is m dot h into CPH is CH. TH1 minus TH2 is equal to m dot C into CPC is heat capacity of cold fluid CC, TC2 minus TC1. So CH value I know. Here is a CH 1256.25. 1256.25. TH1 is 66 minus TH2, just now calculated 26.81, is equal to CC. This is CC 1608. TC2 is unknown and TC1 is 15.5. 15.5. If I will solve this, the answer of TC2 comes as 46.11 degrees Celsius. Okay, here is the end of the problem. Now we'll move to the next problem, and probably that is the last problem in the list for the heat exchanger. Okay, let's write the data for this problem by reading each statement step by step. In counterflow, so heat exchanger is of which type? Counterflow. So draw the temperature profile for it. In opposite direction, cold fluid. This is hot fluid, TH1, TH2. Cold fluid enters from right side, so this is TC1, this is TC2. दोनों का difference θ1, इन दोनों का difference θ2. Okay. Water is heated from, now I will make two column. hot fluid and cold fluid. Now water is heated means definitely water is heat किसका होगा? Cold fluid का होगा. So water is definitely a cold fluid. So Tc1 is given as 25 degrees Celsius, Tc2 given as 65 degrees Celsius. So this is 25, this is 65. With oil, by an oil is heating the water. So naturally oil becomes hot fluid with specific heat of the, so Cph is given as 1450 joule per kg Kelvin. Actually it is 1.45 kilojoule, so convert it is in joule, 1450 joule per kg Kelvin. And the mass flow rate of oil is also given, that is hot fluid, m dot h is 0.9 kg per second. The oil is cooled from 230, so oil is hot fluid, it is cooled from 230, so th1 is 230 to 160, so th2 is 160 degrees Celsius, 160. If the overall heat transfer coefficient U is nothing to do with hot and cold fluid, so it is common data. U is 420 watt per meter square Kelvin. Calculate the following. So what are the required answer? The required answer is number 1, m dot mass flow rate of water. Water is cold fluid, so m dot C is asked. And number 2, area of the heat exchanger is asked. Okay. Now, if you look at the temperature profile diagram, all 4 temperatures are known to you. So you can use LMTD approach to solve the problem. Even you can use NTU approach, effectiveness NTU approach also. But which is the simplest method? If both the options are available, of course LMTD approach. So if all temperatures are known or 3 temperatures are known, we are using LMTD approach. Okay. So what is that? Q is equal to UA theta m is equal to UI AI theta m is equal to U0 A0 theta m. Out of this, if in this problem nothing is mentioned about the diameter of the tube, thermal conductivity of the tube, and that's why I am discarding these two formulae and I am using this formula. Q is equal to general formula, not based on inner area, not based on outer area, because dimensions are not given. So UA theta m, and if I want to know area, I require, if I want to know area, this area, I want to know Q, I want to know U, I want to know theta m. I think U is given directly, so I will tick mark it, no question mark. So only unknown is Q and theta m. So how to calculate Q? Q is equal to m dot h Cph Th1 minus Th2 m dot C Cpc Tc2 minus Tc1. So both the options are available to you. Depending on the data given, you can calculate it. So I think mass flow rate is given only for hot fluid, so I will go for hot fluid. M dot H, how much it is? 0.9. So 0.9 into Cph 1450 into Th1 minus Th2, 230 minus 160. 230 minus 160. So the answer of Q is the answer of Q is 91350 watt. But if Q is known to you, you can equate it with the second equation, that is m dot C Cpc Tc2 minus Tc1. So 91350 is equal to m dot C, that is mass flow rate of cold fluid, into Cpc. What is the cold fluid? Water, and they have not mentioned the value of specific heat of water, so you have to take a standard value. Just 1 minute, something has happened here. I need to recalculate it because it has been vanished, so I will do it again. Q is equal to m dot h. What is m dot h? 0.9 CPH is how much? 1450 into TH1, 230 minus 160. Again the same thing is happening. 0.9 into 1 minute. There is the issue. Okay, this is coming here. I can't undo it. ठीक है. M dot H is 0.9, CPH is 1450. So 0.9, 1. What is CPH? 1450 into TH1 is 230 minus 160. 230 minus 160. If we will calculate, the answer of Q is coming as 91350 watt. But Q is equal to, that is 91350 is equal to M dot C into CPC. Specific heat of water is not given, cold fluid is not given. So take a standard value for specific heat of water, that is 4187 joule per kg Kelvin. 4.187 is kilojoule. So it is joule 4187 into TC2. What is TC2? Something is problematic here. What I am writing on the second slide is appearing on the first slide. So please. So TC2 is 65 and TC1 is 25. 65 minus 25. So M dot C is equal to 0.5454 kg per second. So I think this is answer number 1. Now what is next? They have asked you along with M dot C, they have asked you, this is over now, they have asked area. So how to get area? How to get area? Q is equal to UA theta M. So to know area, I require Q, I require U, I require theta M. So the answer of Q is already with me. So what is that Q? 91350. The value of U is given 420. Only theta M is remaining. So to get theta M, I require theta 1, I require theta 2. What is theta 1? It is a counter flow heat exchanger. So theta 1 is TH1 minus TC2. TH1 minus TC2. And what is theta 2? TH2 minus TC1. TH2 minus TC1. Just put the values. 230 minus 65. 230 minus 65. And here 160 minus 25. 160 minus 25. So 230 minus 65 comes as 165 degrees Celsius, and this comes as 135 degrees Celsius. So what is theta M? Theta M is theta 2 minus theta 1 divided by natural log of theta 2 by theta 1. If I put the values, 135 minus 165 divided by natural log of 135 divided by 165, if I will solve it, it comes as 149.49 degrees Celsius. Now you are having everything with you. Area is equal to 91350 upon 420 into U is 420 into theta M. Just now calculated 149.49. So area answer is 1.4549 meter square. So this is your answer number 2. Students, because of some technical difficulty, what I have written over second slide is vanished, but you are having a previous recording, and from that you can collect the values. Okay, so both the objective, that is M dot C and area, both the objectives I have fulfilled. If you want, I will replace it again. Q is equal to M dot C is 0.9 into 1450. Okay, here again it is something problematic. Whatever I am writing, it is coming on the slide number 1. So I'm better, I'm not writing anything here. Okay, so that's it. All the heat transfer, that is heat exchanger related problems, we have solved. Lot of variety I have covered. Almost 12 problems solutions I have given in 4 to 5 lectures, I think. So from my side, I think it is enough practice. You can solve these on your own by using calculator. Just don't see the videos, don't just read the problems. You have to do each and every calculation on the calculator, because the practice on the calculator is must. You have to remember the formulae, which formula used where, which formula should not be used. There are certain rules, so that you have to remember. Some rules I am going to teach you in theory in detail. Accordingly, you have to proceed for solving the problem. But remember, practice on the calculator is must. So that's it for today. So here with this, I am announcing the end of heat exchanger. Thank you.